Welcome back from spring break. I'm going to go through the last 3 problems of the homework before spring, or not the homework, but the assignment before spring break. I'm suspecting there's a lot of questions about those 3, so I'll do them on here, and then in our Zoom meetup, feel free to ask me further questions about those 3 or any of the others that were on that assignment. All right, you're going to be ahead. Period 6, you're going to be ahead of period 1 since we had a double B day. So this is kind of a little lighter review of what we did before break. And so I do want to, first before I get into those 3 problems, just review quickly the theorems that we talked about. So we had the perpendicular radius and chord. So in a circle you had, here's the center, you had a chord, and the chord was not a diameter, and then there was a perpendicular radius. So if that's the case, then you know that the chord is being bisected. And then also if you know that the radius is bisecting a chord, then you know that these guys are the radius and the chord are perpendicular, so it's kind of the reverse. And then also, if a perpendicular bisector of a chord passes through the center of the circle, so you know that if you've got a situation where this is happening, you know that this line will continue and hit the center. So those are the things we talked about in the first section. In the second section, hope you like popcorn. My son just made us all popcorn. I'll let you know how it tastes. Okay, so then the second section was talking about these chords again. Boom. And it said that if you have 2 chords that are equidistant, so this line from here, which is perpendicular, and this line to here, which is perpendicular, if these 2 lines are congruent, then you know that these 2 chords are also congruent. So if 2 chords are equidistant from the center of a circle, then they are congruent. And then you can also reverse it and say if 2 chords are congruent, then they're equidistant from the center of the circle. So those are the things that we talked about before break. So then let's go ahead and do those last 3 problems from your assignment. Number 13 says that a 16 by 12 rectangle is inscribed in a circle. Find the radius of the circle. So inscribed, in meaning inside of, right? Scribed being drawn. So inscribed, here's our rectangle. It is inscribed. Oof, that was hard. And it's a 12 by 16 rectangle. They want to know what is the radius of the circle. Or find the radius of the circle. I was reading 12 for a second. All right, so we've got some triangles if we draw these out, right? And let's say we draw this perpendicular line. Well, then that's going to split this chord into 8 and 8, right? And we know that this piece here is 12, and we need, so if I draw one here, I can do 6 and 6, but I still need this radius. Sorry, that's not a radius. I still need this radius here. So this is our unknown. We'll call it x, 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 and x. All right. So let's take a look at this. This triangle here and this triangle here, they share x, right? They both have x, so we can say in this case, we'll call this guy y. So 8 squared plus y squared equals x squared. And then we'll call this one z. It's different, so that'll be 6 squared plus z squared equals x squared. Oh, that's interesting. That's not going to work, right? Because we have 3 variables and only 2 equations. So bad approach. Let's try something different. Let's try a different triangle. Let's look at this guy over here. Let's see, that's 8. That's 6. That's x. So that makes this 6, doesn't it? We have a little rectangle in here. See that? I should have seen it in the first place, but I didn't. I had to go through this mistake. That's okay. So we know that this rectangle is a 6 by 8 rectangle. Well, hey, isn't that a right triangle? Right? Triangle. We've got 8 and 6. And isn't that a family? 3, 4, 5. So this should be 10. All right, so the radius is 10. Okay, let's look at 14. I wonder if 14 will be as tricky. Maybe it's trickier. Who knows? All right, number 14. You are given, it's a proof. So let's look at this guy here. Here's our circle. And we know, let's see, there's this and this. This is P, Q, R, S, T. And we are given circle O. And we know that PQ is congruent to TS. PQ is congruent to TS. They're congruent chords. Think about that for a second. We want to prove that RQ is congruent to RS. Sorry, I wrote that kind of weird. Okay, so we have congruent chords. Think about that. Congruent chords are equidistant from the center. So we know that this line and this line, so long as they're perpendicular to the chords, are going to be congruent. So we can draw, what do we call this, X and Y? Draw OX and OY since 2 points determine a line. Thus, OX is congruent to OY because PQ is congruent to TS, and congruent chords are equidistant from the center of the circle. All right, so I've got this piece here. All right, we want to show RQ and RS and RQ are congruent. Well, how about we draw another line? Let's draw in some triangles here. So draw OR since 2 points determine a line. And so OR is congruent to OR by the reflexive property. And triangle XOR is congruent to triangle YOR by HL, right? Thus, by CPCTC, XR is congruent to YR. Since PQ is congruent to TS, and remember back to section 1, which talked about the chords that are perpendicular. It said that if a radius is perpendicular to a chord, then it bisects the chord. Since PQ is congruent to TS and OY is perpendicular to TS and OX is perpendicular to PQ, PQ and TS are bisected. Thus, YS is congruent to XQ. By division, sorry. Therefore, I'm going to do my little therefore, QR is congruent to SR, right? RS. SR. Therefore, QR is congruent to SR by subtraction. There we go. That was not easy. That was not an easy one. Had to remember stuff from the last section and this section. All right, and then 15 I thought might be a little bit of an algebraic challenge for you. So let's look at 15 real quick. And then we'll be done with this video and I will see you in our Zoom. All right, so we've got, this is our image here. This triangle is inscribed in the circle. And there is a perpendicular, the chord is perpendicular to that little bit of a radius. So we know that ABC, triangle ABC is isosceles. And AB, A, B, C, D, E, F. We know that AB is congruent to AC. We have AD is perpendicular to BC. And we have that AF equals 6 and ED is 1. We need to find the radius of the circle. So let's draw in a radius. This might be helpful because there's a little triangle there. We want to find that. We'll call it X. And let's see, what do we know about this? Well, if this guy's 6 and this is perpendicular to the chord, we know that this is 6. So this is a 6. That's an X. That's 1. Let's see, we know these guys are perpendicular, but we don't know anything about it. So let's call it Y and Y. All right, let's look at our triangles here. We have this right triangle here, so 1 squared plus y squared equals x squared. And then we have this triangle, this guy here. Oh wait, what's the length from A to E? A to E is a radius. What did we call our radius? X. So looking at this triangle here, we have y squared plus, this would be x plus 1 quantity squared equals, the hypotenuse is 12 squared. Okay, so let's see what we can do with these. It looks to me like both of these equations have a y squared in them, so let's isolate the y squared. For this guy here, y squared equals x squared minus 1. Agreed? We isolated y squared. For this one here, y squared equals 12 squared minus x plus 1 quantity squared. Now I can set these two equal to each other. So x squared minus 1 equals 12 squared minus the quantity x plus 1 squared. All right, ready for algebra. Here we go. X squared minus 1 equals 144 minus, this will be x squared plus 2x plus 1, FOIL, don't forget to FOIL, and then distribute your negative sign. 144 minus x squared minus 2x minus 1. All right, let's set it all equal to 0. Add x squared to both sides, so I've got 2x squareds. add 2x to both sides. So that's gone and that's gone. Add 1 to both sides. That's going to be a 0. And then subtract 144. All right, these are all divisible by 2. So let's do that. X squared plus x minus 144 divided by 272 equals 0. Factors of negative 72 that add to equal 1. So x minus 8 and x plus 9 equals 0. So your two possible solutions would be x equals 8 or x equals negative 9. Remember, we're talking about a distance, so we can say goodbye to our negative. That doesn't make any sense in this context. So x, the radius, is equal to 8. All right, give those 3 a try on your own now. Now that we've gone through all of them, try them again on your own, and then we're going to meet up and we'll talk about this and or other things. See ya.